first part of this, we have two stages. You have one stage. Second stage of this, the only thing that's acting on it is gravity. It thrusts for 1,000, and then it shuts the thrusters off, and then it just sails for the remainder of it. So what you need to do is you need to find out what V2 is in order to get your acceleration in your first part. Your acceleration in your first part will help you get your thrust force, which is an applied force, minus your force of gravity. So you need to get your A value right here, add your force of gravity, and then you'll know what the thrust force is of the rockets. So again, you're just using the same equation for both of them. The first one you're solving for V1, the second one you're solving for A.
So thrust is the same as applied?
Yeah.
Why do you call it thrust?
Because that's what, like, you're using rockets, so they say it's thrusting.
Okay.
Okay? So there's all the information that you need to get that question done. No problem. All right? Other questions today?
Yeah.
Lex?
Question from the NRD.
28. What is moving the two objects? On which one? The
Oh,
what?
wait. 3.2.
So you have the force of gravity on the 3.2. And what's holding it back?
Force of gravity on the back. The tension.
What is holding it back?
Tension, just tension.
No.
Force of gravity on the back.
No. Is the force of gravity, is the 5 kilogram one hanging? So then how can it have gravity affecting it? Because the normal force is pushing it up. Which is what? There. Now you can get your acceleration. The only time you have force of gravity minus force of gravity is if you have two of them hanging. Then one's preventing it. Now once you do this, you get your acceleration, then you can find your tension after on the individual ones. So if you're looking at the individual, if you're looking at the force net on the 5, it's tension minus force of friction. If you're looking at the force net on the 3.2, force of gravity minus your tension. So you find everything that you need with both of them first, and then you individualize it in order to get your tension. The only thing that can hold something back is friction, unless it's hanging, and then the other force of gravity is holding it back. Look at the diagram. Right? So all the questions you've done so far didn't have force of friction on this one that was sliding. Did it? Okay. I am going to, I want to show you that next one, because I am going to ask this on the test for sure. one is a little bit different because you have a little bit of force of gravity affecting the one that's on that, on the slant, on the slope. Okay? So, we know that the force of gravity is going to move both of these. So to calculate my net force, it's equal to the force of gravity minus. So what's holding this guy back then?
Tension.
No. You do not use tension ever when you're finding your acceleration initially. The tension is only on the individual mass. We don't talk about tension. They're connected. So it's what's moving this guy and what's holding it back. Well, this mass has to be holding it back, right?
Right.
So it's got to be moving, it should be moving this way. If it was not attached, it'd be sliding down that way, right? And what do we call that force?
Applied.
It's called an applied force. So that's actually holding it back. So what you have to do then is you have to find out what that applied force is. So that's holding it back. Now, is there friction in this question? Yes, there is. So I actually have to do this as well. Whoops. I have to add both of those together. Because the applied force and the force of friction are working in the same direction. They're opposing the direction of motion. This guy is going to go like this. Right? Unless this force was somehow smaller than those two forces there. But because of the same masses, you can clearly see that the force of gravity has to be greater than the applied force. Because the force of gravity is the same here, the applied force is half of that because this angle is 30 degrees. So when you're doing this question, to find out the acceleration of it, the force that's moving them is this force right here. The force that's holding them back is the applied force going down, and the force of friction, because that's also affecting it, going up. Then from there, all you have to do is find out all of your individual pieces of information. It gives you a coefficient of friction, so you need your normal force. So you have to use your triangle for this. Okay? This one incorporates everything you've done with the block sliding. Alright? Force of gravity applied, normal. We've done that. Done that 3 or 4 times now. So we have to be able to follow that, use that triangle. All that we've added to it is now, instead of everything working in this direction and the friction working against it, now I'm moving it because of this guy right here. So now all I do is acceleration is equal to force gravity minus force applied plus the force of friction over my mass. Alright? Okay. You will see 2 pulley questions on that test for sure. Then when they ask you for the tension, then you can do the individual forces. But when I do tension, I probably only want to use this guy to get your tension. This one will be tension minus applied minus force of friction. So there's a little more work with it. But you need to know all of these. Okay? Yes. fired.
I can do the ones where it's going up horizontally, but this one's different because I have to go up first, so I can't do it. Which one are you doing?
Question 43. Okay. Alright, fired at 200 meters per second, right? An angle of 30 degrees. Okay, so I'm gonna do this in 2 stages. I'm gonna find out the amount of time it takes to get to its peak and how high above the cliff it is. So I start by V1. My V1, this is 30 degrees here, right?
Yeah.
Therefore, my V1 is 100 meters per second. So I get that V1 is 100 meters per second right there. A is negative 9.8. V2 is 0. I need to get my D and I need to get my time. Okay? So that takes me to the peak. Alright? My second stage is I'm going to go from here down there. So in that case, my V1 is 0 meters per second. My A is 9.8 meters per second squared. My D will be whatever 125 plus that is. Okay? And then I can calculate my time it takes to fall. Alright? And then the question says, it wants to find out how far this is right here. Well, my velocity is whatever this is right here. And the amount of time it takes to hit the ground is this added to that. Okay, so this is a different question than what you've done. Alright, so what our goal is, how long does it take to get here? That's my time. And how high above the ground is it? So you find those two. Once you have that, then you have to find the time it takes to fall from the top to the bottom. Okay, and the distance is whatever this is about plus 125. So you only have to find the one blank here. Because you'll count these two here, and the D goes there. Okay? So, difference being, we're on a cliff this time as opposed to level ground. On level ground, you only need to find this times the time by 2, because that'll take you to right here. Right? And you can do it that way. You could actually do this a different way. You could find out that amount of time it took to get here, and then from here to the bottom of the ground, that'd be how long it took to drop it. So you could find it that way too. Where your V1 is 0.
So then would I use my velocity, my horizontal velocity to find instead?
Down here.
Yeah.
Use your horizontal velocity times the time.
Because I'm using my V1, my
You-
vertical for the other one.
For which one? For down here?
Like
There. That's your V1, yeah. But you could find it, how long it takes to get to here, which is back, even with the cliff. And then you could go V1 is 0, cliff's 125. So you can do this 2 different ways. But this is, to me, this is the easiest way. Find out how long it takes to get to its peak, how far is that above the ground, and then start it all again. Find out how long it takes to hit the ground,
As if I'm just dropping it.
as if you're dropping it from there. Because once it goes to its peak, it stops, right?
Yeah.
And then it falls down. Okay? Alright? Sam, you had a question?
Yeah, 22.
Uh, just in there for funsies. Okay, so, this is your tension, this is your force of gravity here, right? So your net force, usually your tension minus your force of gravity, because she's gotta go up. Alright? Now it says that Jane wishes to scale the line to safely support the combined weight of Tarzan, Jane, and Cheetah. Tarzan has twice the mass of Jane, who has twice the mass of Cheetah. Okay? So, Cheetah is X. Jane has twice his mass. Tarzan has twice her mass. Okay?
Yeah.
So she's climbing it, so her mass is 2x times her acceleration. Just leave it. Watch. You're just copying, you're not learning anything. How much can the vine hold? It's the maximum tension.
Should it say?
Yes, it does.
Support the combined weight of Tarzan.
Okay, so how do I show that? So what does that equal? 7x. Right? Times 9.8, because that's the combined, that's the force. Subtract 2x times 9.8, that's her. Okay? So now you would combine this and then divide by 2x. So you're going to get, your x's are all going to cancel because they're all masses. Okay? This isn't a test question, this is just a question that's in the book to see if you can work through it. Which you can.
No, I can't.
Okay. All right, anybody else? Dalen?
45.
Okay. So bomber drops a bomb. Okay. What's he flying at? Doesn't say, right?
He's diving.
He's diving. So,
And the altitude is 730 meters.
okay, so your D1, do I want to do this? I think so. 0 meters per second. D is 730. A is 9.8. Let's find the amount of time it takes for it to hit the ground. Your bomb.
Okay, I think I can do it now. I just didn't get the V1.
Okay. Now, just a second on this though. Let's calculate this and then let's check and see if I can get this right on the. Okay. So. I need V2.
Is it like a two-step question? Because he dives.
Yeah. So I need V2 and then I have to use right angle trig to get this here. Oh, we know the time. Time's 5 seconds, right? Sorry. I'm gonna do this differently, Dylan. I wanna find that. normally I just drop something, right?
Yeah.
But because I'm going towards the ground already, I have to have an initial velocity. So that's what I'm gonna find right now. Alright, so I've got delta D equals V1 delta T plus 1/2 A delta T squared. Right? So I've got 730 equals 5V1 plus 4.9 times 25. 4.9 times 25.
122.5.
22.5?
Yeah.
So I have that. So what that's going to give me is it's going to give me my initial downward velocity. Then I use right angle trig to get what the velocity of the plane is. So 730 subtract 122.5 and then divide it by 5.
Yeah.
What'd you get?
Well, I got 121.5, and she got that too.
So you got 121.5 meters per second. Okay? So that's the adjacent side. That's the hypotenuse, right? So cos 53 is equal to 121.5 over velocity. Velocity is equal to 121.5 over cos 53.
201.88.
There's your answer. Okay? So you follow what the reason I did what I did?
Yeah.
Normally when you drop things, it's your V1 is 0, right? But because you're moving in the direction that you're dropping it, that means you have an initial velocity.
Yeah, I don't understand how your V1 is equal to the hypotenuse.
Plus-
Why it's there and not.
It's not equal to the hypotenuse.
No,
of the
like why
triangle.
is it there? Like why isn't it?
I don't understand your question. Say that again. Why is V1 where it is?
Yeah.
Because that's you have two components. You have somebody moving this way, right? So there's a down component and a horizontal component. So what's the initial down component is right here, is your V1. So let's say I was standing up on a cliff and I threw a ball down on an angle like this. Okay? Well, I'm throwing it with an initial downward speed, but I also have some sort of horizontal speed as well. Right? So if you find this velocity now, using trig, and times it by 5 seconds, because that's how long it takes, you'll find out how far it went from here to here.
I see. I get it.
Does that make more sense now?
Yeah.
So basically, if you think about it like this, Dalen, if I took this triangle and I rotated it, it'd be the same thing as if I threw it up in the air.
Mhm.
It's the same question as if when I do this. Okay? My initial velocity is whatever I throw it up at.
Yeah.
Same thing here, just rotate your triangle and you have the same question. So all my projectile motion questions and this are the exact same question. The only difference is one's going up and one's going down. Does that make more sense? Okay. Anybody else?
Number 20. Very good.
You have force of gravity and you have tension, correct? So he's going down, so which is the larger?
The force of gravity.
mass.
0.10, or I converted it to 0.0001 because it has to be kilograms.
Okay? Times A. Right?
Right?
Force of gravity of him, 0.1 over 1,000, times 9.8. And its tension is 0. Oh, gives it to you. Let's give it to you as its tension force. 5.6 times 10 to the negative 4 newtons.
I didn't think of that as a tension force. I did something completely backwards here.
0.1 gram spider is descending on a strand that supports it with a force of, so the strand supports with a force of 5.6 times 10 to the negative 4.
The tension is between the spider
On the string.
and the string.
Yes.
Okay.
So this box represents your spider, and that's the string.
Okay.
Like just think about a spider hanging on a web.
Oh yeah.
That's what's happening here. Okay? Can you solve it now?
Yes, I can.
Okay. So you didn't put these together.
I put that number beside A and another number.
Yeah, but beside A needs to be a mass.
I think I used the wrong equation.
There's no equation to use. You're just using the same thing every time. Force net is equal to what? What's moving it, what's holding it back? Force of gravity minus tension. You okay? Can you finish this or no?
Yes, I can.
Okay. Okay, anybody else today?
Yeah. It's okay. Well,
Anybody else?